There's never enough time. I might even be doing a lecture this weekend just to get some videos out about what I don't cover because we have so few classes left. So we got, when we're acquiring assets up to this point, right? We were always, our focus was really on, do I debit an asset? Do I debit an expense? Do I capitalize it? Do I treat it as an expense? What are, basically what are the types of things I can find in PP&E and intangible sections? We talked a little bit about it, ARO, which is getting into the means of acquisition. But now we're going to talk about the dollar value. And the general rule for this is the asset needs to be recorded at the fair market value of what is given up to acquire it. Or its own fair market value. So if I'm giving up maybe equity, which, of course, stock, maybe I'm giving up some common stock in my company to get something. Maybe I'm giving, signing a note payable. I don't want to pay cash for it right away, so I promise to pay later. Of course, I could be giving up cash. I could be exchanging an asset for an asset. So there's lots, or I could be doing a combination of things, of any of those and more, right? So what is the fair market value of the equity I'm giving up, this note, the cash, the asset I'm exchanging? I could either come at it from that, what I'm giving up, or I need to assess what is the market value of what I'm getting. And it's whichever is more clearly evident. Typically, this is going to be what I'm giving up is more clearly evident. So this will usually win, except in unusual cases. So let's first talk about notes and deferred payments. And this is where time value of money is going to come into play once again. So we're talking about notes payable with stipulated sums of money that are payable at specified dates. There can be two types of notes. It could be a lump sum note, and that's just a single payment at a future date. And ARO is a lump sum amount. It's not a note. It's a different sort of contract, but it's still lump sum, just one amount paid in the future. Installment notes are a series of payments over time. So I have to pay $100,000 every year for 3 years in order to meet the requirements of the note. Accounts, when we acquire assets with long-term credit contracts, i.e. notes payable, and they're long-term. So that's something that is important beyond a year. Oops, beyond a year. We want to record the contract at the present value of the future payments required by the note. So the same thing as we did the ARO, we might owe $300,000 3 years from now, but the present value of $300,000 is actually less money because I don't have to invest $300,000 today to get $300,000 3 years from now, right? There's always interest, at least there's always going to be risk-free interest I can earn on money. So therefore, the present value, the value of $1 today is worth more than the $300,000 that I'm going to pay 3 years from now. There may be what we call no stated interest rate on the notes. It could be called, a non-interest bearing note. And that just indicates that we don't have to pay periodic interest. They will still contain, and I mentioned this before when we're talking about notes, still I was trying to think of a better word than contain implicit interest. So there is going to be an interest factor. It's just implicit. It's not spoken, but it's in there, right? It's not stated, but it's still there. So there can be a number of factors. The payment, the things you saw on the financial calculator that I pulled up on the internet, there's a payment, a stated interest times the principal. That is only, or lump sum payment for the lump sum payments. If there is no stated interest, so for these non-interest bearing notes, then the payment is zero. If there is an installment note, like I said, $100,000 every year for 3 years, then we don't have a specified future value. We don't have one single amount. We have 3 amounts of $100,000. Those would be $100,000 PMTs over the course of 3 years, no future value. Okay. So in what I want to emphasize more with what we have, you can, like notes, there could be so many different types of notes, but what I'm going to emphasize most is lump sum, zero interest, i.e. non-interest bearing. And also installment payment. So those are the 2 types of notes I want you to become familiar with when we're working through these. Either I'm buying something, it has a no stated rate, it's a non-interest bearing note, and $300,000 is due 3 years from now, or it's an installment note where I don't have one lump sum due at a specified time in the future. I'm paying it off every year for a number of years and transferring that amount of money at those times. So that's the payment. The FV is the lump sum future payment. Installment notes have no future value. Their FV is 0. N is the length of the contract in years, and I is the rate of the market adjusted risk for the company acquiring the asset. Sometimes it's just called the discount rate. We solve that again with our ARO. So after we get these factors, we can use them to calculate the present value of a note. Like I said, you can use a financial calculator if you want. I have no qualms with that. And I will also provide present value tables, and it's required. I don't know why they still do this, why they just don't allow financial calculators on the CPA exam. And then look up the N and the I to establish the present value factor that that will discount the payment and the FV. So let's look at an example of this. On January 1st, Vivo purchased equipment in exchange for a non-interest bearing note, requiring 3 payments of $20,000 at December 31st each year for the next 3 years. Suppose Vivo is paying 7% average interest on notes with similar terms. So I'm actually this time going to look up the present value of an annuity table. And they're actually harder to find sometimes, these on the internet, than it is just to find a calculator, but I found one. If I can get it to a good readable format. All right. So this is, the example of the table that I was talking about. You have periods down the column. You got interest over the, periods down the rows, interest across the columns. We're looking at a 7% average interest on notes with similar terms, 3 payments. So our N is 3 and our I is 7. So it looks like we're going to be using that table factor right there. I'm going to write it down. So I equals 7%, N equals 3 corresponds to a table factor of 2.62432. All right, so we got that. This is my table factor. I'm going to take that, multiply it by the payment. I have no future value, right? There's no future value. It's just all I'm doing is having a string of payments here. 1, 2, 3, 20K, 20K, 20K. So there's no like, if I put in a future value to this, it would be like, if I logged a future value into my present value calculator and also included 20K, N equals 3, I equals 7. If I put 20K FV on top of that, it would be like saying, oh, I have another 20K payment, including the one I'm already imputing because I put 20 payment equals 20K for 3 periods. So you don't want to do that. FV equals 0. So I'm just looking at what is the present value of this string of payments. In order to calculate that, all I take is the payment amount, 20,000, multiply it by the table factor. And too much math for my head right now, 20,000 times 2.6 gives me $52,486.40 if I don't round. So what this is telling me is this is the present value of 3 $20,000 payments over 3 years at 7% interest. And notice it's less than the absolute sum of these. The absolute sum would be 60,000. Well, today, those 3 payments are not worth 60,000. They're worth $52,486.40. So this is how much the note would be valued at in a present value sense. Now, when we record this equipment, we got to record at the present value. We're receiving this equipment today. And therefore, we record it at the present value of the note, $52,486. I'll round it at that point, round it down. Okay. This is telling me that I'm indifferent. Like if I'm the person who's selling this, I'm indifferent between receiving $20,000 every year for 3 years and receiving $52,486 today. That's my equivalence there. If I bought it today, I would need $52,486 of cash. But if they're not going to give me cash today, they're going to sign a note that they're going to defer payments over time. Then to get my 7% amount, interest that I want from them, then I'm going to get them to give me $20,000 at the end of every year for 3 years, because the absolute note is valued at 60,000. I'm going to make, 3 $20,000 payments. The note payable is going to be recorded at 60,000. So this is always recorded at present value. This is always recorded at not future value, face value. So that's the, face value is the amount that is required to extinguish the note. It does not include interest. It does not include anything like that. Now we have a discrepancy between our 2 amounts. Debits don't equal credits. And the note payable, if it's left at this value, is not at present value. It's at its face value. So we have to add, because we're crediting a note payable, And our ledger would look something like this. Then we have to add another account in order to get the amount that I would put on the balance sheet at its present value. We record a discount on the note payable for the difference between the two, which comes out to $7,514. So this is a contra account. Oops, sorry, it's contra and I'm writing it on the wrong side. It's a contra liability account. And like all contras, I subtract this from its parent account when reporting it on the balance sheet so that the note payable would be expressed on the balance sheet. Make that clear that this is what I'm writing up here, just like a very partial balance sheet with one account. $52,486. It would be at that value because we're going to take the contra, subtract it from its parent, and then when we're reporting it on the balance sheet. This is the present value of the note. And just to reinforce what it's not asked for here. Oh, I do say as well as the first installment payment. And to reinforce the ARO, at the end of the year, I have a payment and implicit interest to record. The payment's pretty easy. I'm paying $10,000 cash, and that's going to reduce, I'm sorry, 20. And that's going to reduce the value of the note payable. So I'm paying directly down the principal. There's no interest to pay down first. That's taken my note payable. Eventually it'll be credited for 20,000 because it was at, I'm sorry, debited by 20,000. It was at 60,000. But before that, I also have to show that just like the ARO, this is its present value. And as we get closer to the settlement of the financial instrument, to the settlement of the obligation, the present value will shift. There's going to be a slight increase. Now, there's going to actually be two effects because we're paying off a bit and we're going to have a slight increase. But this increase is the same as what we did with that ARO to show that over time, present values rise as we get closer to settlement dates. So the way we calculate it is the same. We take 52,486. That's the present value of our instrument at the beginning of the period. The present value of that note payable. Multiply it by the rate at which it was discounted. I used a 7% rate to come up with this present value. So that's the rate I'm going to apply to it. 52,486. And then in my calculator, I still have the 0.4 just in case you're doing this on your own and you're wondering why you might be just a tiny bit off. 3,674.05. I'm definitely going to round that off. This is the amount of interest that I record. Remember, I said, hey, it's not interest bearing, but because we're doing a present value, there's going to be some interest growing over time that we're going to pay out. And the credit is not to the note payable directly. The credit is to the discount. That's a big difference between the ARO accounting and notes accounting. We do not credit the note directly. We did credit the ARO directly. But in this case, we got a contra account hanging out that we need to slowly reduce over time. This is called amortization of the discount. It was established at 7514. At the end of the first year, I'm going to swipe off $3,674 of it. And that's going to get me 3,840. That's the remaining discount. Now the note payable underwent a change too. At the end of the year, it's now only $40,000 remaining. On the balance sheet then, the new present value of this note is made up of its two pieces, 40,000 less 3,840. $36,160. That is the new present value at the end of the first year. So, you know, I go into a little more detail on this because I find that especially not so much finance students, but accounting students don't really like present value as much. And I know because I was there too when I first saw it. I didn't have someone explain it to me. They just were like, oh, this is the process. Here's an amortization table. And that didn't jive with me. But as I dug through it, it made more sense. And it's really nothing to be frightened of. It is a lot of interest sort of topics kind of tying together, but it's such an important concept and carries forward into intermediate 2 that I want you to have some exposure so that hopefully when you get to intermediate 2, you can just, you know, kind of just cement the foundation that you've already started to lay here. The last thing that I'll mention, and I've mentioned it before with accounts receivable, is, well, why is there interest being recorded here? You know, why are we recording interest expense? And this was, you know, one of those things that I was never taught. I kind of had to figure out on my own, and I don't want to leave you hanging in that place. Because with the terms of this note, remember I said the seller was indifferent to collecting $52,486 of cash today, or $60,000 through a series of payments, right? As the buyer, if I chose the series of payments over paying the cash today, right? The equipment is only worth $52,486. It's not worth $60,000, right? Because that's the amount of money today that it's sold for. Therefore, any amount of money that I pay over this price is interest. The difference between $60,000 and $52,486, we log it into a contra liability, but that total amount represents interest expense. And it goes back to that basic definition that any amount of money I pay over the amount of money lent. In this case, they basically lent me $52,486, but I'm paying them $60,000. Any amount of money, $7,514, becomes interest, and therefore over time, and we want to recognize it over time as we do with any contract over a series of years like this. We're going to recognize a little bit of interest expense every time until this discount is zero, right? So it gets released as interest expense as I reduce the discount on the note payable. So anyway, I know that, you know, think it through, play the video back if you need to. It's not the easiest concept in the world, but if you lock into that, you will make your accounting education so much less painful. And I can speak from experience, having gone through and taught the intermediate series. So that's all I got for today. And I hope you guys have a wonderful day. Don't forget the test is due Thursday at noon. And I thank you for coming. And I hope everything's great. I'll stick around, of course, as I usually do for any questions.